Hi, it's Terry Dennery of the MathWorks. Anyways, that last video was pretty cool how we kind of started talking about feedback and we introduced the feedback on the angle, which is ultimately the desired thing that we want out of this very simple machine, which is simply a DC motor. Okay, but what we're ultimately kind of pursuing is kind of this general format for how electromechanical systems operate and how controls ultimately are developed and are interfaced with such equipment. So anyways, it's cool that we got done what we got done, but I look at the model now and I think it's a bit of a mess, and I think organization is important. I'd also say that compliance with kind of standards is always important, and when it comes to controls, there really is a standard for kind of representing what those systems are, and it generally is thought of as the machine, the controller, the machine. A very highly adopted term is the plant, but it's basically the electromechanical stuff. Okay, there's the control, there's a feedback loop, there's a command, and there's essentially the assessment of how things are going. Okay, so with that in mind, let's pursue that. Let's ultimately convert this into the classic form. All right. So I'm going to begin. I'm going to just kind of delete, these measurements. They're really cool measurements to make, but we're kind of moving forward now. All right, and well, let's kind of get at the machine first, and it's actually not too bad to get there. All right, to me, this is what I'd call the machine. It's the motor, the mechanical shaft, and a measurement on the angle that needs to be reported. And so I'm going to just take every bit of this. I'm going to create a subsystem. Right? And I'm going to call that the plant. Okay. Now pretty much everything else except for the ultimate command in motion and the scope, well, that's the controller, right? And so very rapidly we're getting things to look a lot better, at least to not at least take up so much real estate. And I can hit my space bar and I'm seeing big things again. Now, clearly I don't want my ports labeled 1, 2, 3. I want them to be more descriptive of what they're anticipating for the signal to be received. And in general, I don't like so many signals appearing to me at this level, right? And that's the nature where we're going to move forward with this. But let's get into the plant first. I think the cleanup there will be much simpler, right? And so I'm going to kind of set this up like this. Again, minimize the real estate that we're using. I'm good with the name of this input port, but this one being called number 2 or out 2, that's not good, right? And so I'll just call it angle for right now. I'm going to just leave it at that because there's more work to be done, right? And so the output, voltage in, electromagnetic torque out, angle out. That's where I want to keep it for right now. Right. So now I'm going to go into this subsystem. Right. And again, a lot of the cleanup is just, again, minimize the real estate that's being used. And if for no other reason I can hit spacebar and it all looks a little bigger to me now. I can do even more. Right. How's that? Okay. I like things to be lined up if possible. Right. I like kind of pretty good spacing of where the blocks are. And then of course I like names. Okay. Not exactly sure how this got the name Y, but I'm not crazy about that name because ultimately what it's asserting is the voltage that will be applied to our motor. Okay. Now here I'm seeing, essentially the feedback coming in that is used in the calculation of the error that the PIDs are being operated on. So these are essentially the feedback loops, appear like this now in the control. Seems we can line that up like that. Okay, so that looks good. And so let's label these things. So this is TE, the electromagnetic feedback. And so I'll just kind of throw in the word FDBK. And this is angle feedback. And I think I'll just call it A, FDVK. All right. And I think I'm going to go ahead and delete this one. All right. And that gives me the ability to just drag this guy down like this now. And this is simply tapping into my motion command. Okay, and simply taking the first component of this three-component signal, which I know to be essentially the position, velocity, and acceleration of the trajectory in which we want to move this motor. And I think we're getting pretty close with that. So we simplified the interface a little bit. Probably should stretch things out a little bit. Not exactly sure why this is happening. I might even refer to it as a bug in Simulink that it's sending that way, way down like that. So I'm going to just detach it and reconnect it like that. And at this point, I realize, well, I need a little more real estate because I think those names are important. And if I move this like this, I can stretch it out. Okay. Yeah, I think it's time to give this the name it deserves. Let's call it the controller, right? And what I want to get at now is kind of that the feedback is more than just angle, it's electromagnetic torque, and it's potentially even more than that, right? And so I want to kind of simplify it so there's the simple one clean feedback loop. Again, I'm seeing that that's kind of bugging me, but I'll go ahead and hit that. I'll hit the space bar again. I got kind of a nice kind of a, um, containment of my view. All right, so let's go in here though. And so it's the idea that there's multiple observations that I am going to make that I want to be reported outside of essentially what I'm calling my plant model, right? And and so in hardware, again, this idea that you have a simulation environment that begins to mirror or kind of adopt the same terminology that we use with hardware, it's a great way to go. It means that the hardware people and the software people can talk together. All right. And so the idea of, creating a harness that captures the multiple measurements, a term that's used in hardware is bus, right? And so we're going to introduce a bus, right? And so we go up here and we get a bus creator, right? And what it really means is I'm going to report everything through one signal, right? And so let's space that out like that. Let's go ahead and even delete that. And let's get this bus in here and let's make it pretty big. Actually, let's even indicate why we need to make it big is because we're going to send in 4 pieces of information into it, right? And I'm going to make it even bigger, right? And that I'm going to just call this, now I'll just call it M for measurement, all right? And here's some things that are going to go into it. Okay, one will be the angle. And so I'm going to just take that signal. I'm going to call it angle. Okay, now our controller is a position controller right now, and therefore we don't specifically care on the controller perspective on what the velocity is, but somebody will, all right? And so we might as well get it. So let's go to that velocity, right? Now the controller is controlling directly on electromagnetic torque. So put torque in there. And then the other thing I want is the current. But you can see at this form, current is not known. And here it is though. And in here, we do have access to the torque constant. And we're able to do the simple math between the electromagnetic torque and the current. And so anyways, whether or not I want to expose K to the next level, I'd say me personally, I would not. And I'd just simply go in here, right? Okay, and just deliver out current expressed in amps. And I'll send that into the bus too. Okay. Okay, one of the things I really like about the way we're doing buses at MathWorks is now if I come in here, Well, we can see that all those names were adopted, and that's how we will refer to it, right? And so we're looking pretty good at this point. So we've established our bus. We're sending it out in one signal, and we're just calling it M. Let's go ahead and delete that. And let's just go into the controller and let's accommodate that, all right? And I think I'll just go ahead and delete that guy, take this guy, make sure, are we still connected? Yes, we are. All right, M's coming back. I'm calling it A feedback, but now it's more than just A for angle, and let's just call it feedback. All right, and let's get the bus selector. Okay, and notice it kind of knows what's on that bus. Again, those names, we're speaking, you know, English here or whatever language you choose to express your signals in. And we're using good grammar too. All right. So let's go ahead and remove that. Okay. And we will select for report from this bus the angle as well as the torque. All right. And I'd say we're getting pretty close to the classic form. I'll just kind of, again, let's check and make sure we did all that right. Let's pop that in. And we'll hit run. Oops. Again, it's angle only, not the entire measurement of what's contained on the bus. And so we'll get our bus selector here. Hit the space bar. Let's try that one more time. Okay, so we're looking pretty good. All right, thank you.